Hi, this is Necklace, the Balancebot. This is Necklace doing his balancing, which he learned through reinforcement learning last time. And by the way, the voice you are hearing is mine. So Necklace is not satisfied by just balancing and standing still. Just like us, if we get a Segway, we want to ride it around. Let's see if Necklace manages to take his skills to the next level. Before touching the learning side of things, I had to make a few tweaks to the physics parameters to make Necklace more mobile, whether Necklace himself likes it or not. One issue I noticed right away is that Necklace does not stay in his lane currently, which means if he wants to go to the target, the network must learn to steer. The action command used previously for pure balancing task was a percentage of the maximum wheel torque that is applied equally to both wheels. But Necklace now needs to control the two wheels separately. So, since I'm doing discrete control, at least I need to double the amount of options. One set of control options for the left wheel and another set for the right. At each step, the neural network picks one out of the two N options, which controls either the left wheel or the right wheel, but not together. If I really want to have truly independent and simultaneous control of the two wheels, I will need N squared options. That's a lot, and that is the motivation for using continuous actions. But since I'm just learning the DQN algorithm, and it only supports discrete actions, let's see if it will still work given all the compromises. Steering a Balancebot is easy. Turn one wheel faster than another, it rotates. But the trick is to rotate while maintaining balance. As before, let me use 60 seconds to explain how this task can be solved using a simple approach. Call it the baseline, and then see if reinforcement learning can do a similar or better job. As mentioned in the previous video, to balance, Necklace just needs to accelerate in the direction he is falling, and the tilt angle will be reduced. Then by adding a simple logic to make one wheel faster than another based on the direction Necklace wants to turn, I can control its direction. Now how do I make it move forward or backward? It is also very simple. If tilting forward causes the wheels to accelerate forward for balancing purpose, it also means the robot will move forward. So, instead of trying to balance around zero tilt angle, asking it to maintain a small but forward tilt will cause the robot to move forward, and a backward tilt would move Necklace backward. That's it. Use wheel speed differential for steering and use the tilt angle set point as your gas pedal, on top of the existing balance control. And Necklace can now move to its target. On the left you can see which wheel is being controlled at what torque level. It is alternating between the two wheels, and the negative torque direction drives the robot forward. But it still doesn't know when and how to stop though. But that is also doable. Just use the distance from Necklace to the target to adjust the tilt angle set point. If Necklace is far away from the goal, use larger tilt angle to run faster. Gradually reduce the speed as it approaches the target, and in the case it went over the target, use a negative tilt to bring it backward. But I'm lazy. I will just ask DQN algorithm to learn all of this while I cross my fingers and wait. One thing I firmly believe will always make my life easier when dealing with complicated problems is to divide and conquer in baby steps. So, step number 1. Let's see if Necklace can still learn to balance as before now that it is controlling the two wheels separately. And it was easy. Without changing any of the default learning parameters, Necklace learned to balance without falling in less than 5 minutes. It also appears that he learned to balance by mostly using one wheel. But what can I say? If it works, it works. Next challenge. Can necklace learn to rotate while balancing? Here I added a small penalty for deviation between its current direction and the target direction. Again, all settings at default, and necklace learned it without breaking a sweat. Here the target direction is always pointing forward, but in each episode, necklace is spawned with a random orientation. So effectively, it has learned to rotate to face the target no matter what its current orientation is. And moving on to the final challenge. Once necklace has turned to face the target, can it move there and stop? I added another term to penalize the distance away from the target. And 30 minutes into the training, nothing has been learned. Necklace falls within 17 steps and collects only some negative rewards. Maybe the negative reward is the problem here. After a period of exploration, and necklace could not manage to receive any positive reward, he's so ashamed of himself that he decides to end his little precious episode by falling early, to avoid any future embarrassment. That is not good, whether in life or in simulation. If the learner keeps getting frustrated and giving up, it won't collect any good experience to improve future rewards. So, I'm going to make necklace feel better by setting a maximum limit to the penalties, and make sure that the reward per step can never go negative. Hopefully this encourages the algorithm to never give up on itself and always have something to look forward to in the future. And that little change has made a big difference. After 300,000 steps, it learned to balance and move forward. And at about 700,000 steps, necklace is able to stop pretty precisely at the target. Nice! I know what you might be thinking. So it is always moving to the 0,0 coordinate location. How is that useful? Well, a coordinate system is a relative concept invented by humans to make things easier. There's nothing preventing me from switching to another coordinate system at any time. And now that necklace has learned to always move to the origin, I can guide its path by updating the coordinate system. Just like a donkey and his carrot. And that approach does work pretty well. However, thinking again, I have used the coordinate conversion trick to simplify learning. I have also used human intuition to break down the task into rotation, moving, and stopping. And I did it by setting up the reward function that way. Am I micromanaging too much? A more satisfying version is to only reward necklace for arriving at the target and not caring how it gets there. So I tried that as well for comparison. With the increased freedom to learn, necklace decides that he wants to back into his parking spot. That's a new skill, and whatever freestyle that was afterwards. But the success rate was not great. Maybe it is limited by the learning algorithm. Maybe I need to do hyperparameter tuning. But that's it for now. I will keep trying and learning. And see you in the next video.